So today what we're going to do is we're going to look at a few more geometric facts, just the background information that will allow us to work and move forward in our look at geometry and measurement. And the first thing we're going to talk about is we're going to go back to those angles and talk about some of those angle properties. Okay? So I'm just going to go to the book for this and then we'll take our notes from there. So the first thing we want to talk about is something called angle pairs. Now, angle pairs means you have two angles, and there are specific ideas about them that you need to be familiar with. And you've seen these before probably in the past, but we need to make sure that you remember them. And the first one is we're going to talk about what are called complementary angles. And complementary angles simply mean two angles, because these are pairs again, remember, two angles that add to 90 degrees. So, in other words, two acute angles that would add to make a right angle, 90 degrees. And you can kind of remember the word complementary goes to 90 degrees because CO starts with the same start as corner, and a 90 degree angle makes a perfect corner. So two angles that add to 90 degrees are called complementary angles. Okay? The second one is something called supplementary angles. And for supplementary angles, that just means two angles that add up to make 180 degrees. So in other words, two angles of any size that will combine to make a straight angle, 180 degrees.
One thing that is different this time around is
so
there's no north
you
boundary.
need to make sure that you remember these.
Southern boundary. With
So you
Northland
must
and
know
Northland
these
treated as one whole.
to know the difference and know how to find them. Because what you'll be doing in some of the exercises, it will say, if one angle is 30 degrees, what is its complement? If one angle is 120 degrees, what is its supplement? So it's important that you know not only that they add to 90 and 180, but which one is which. Okay? All right. The next thing we need to talk about is the idea of vertically opposite angles. Okay. And here's a picture of vertically opposite angles. What that means is two angles that are exactly across from each other. So they occur whenever two lines intersect. So here, if I call this one angle A and this one angle B, because they are straight across from each other, they are called vertically opposite angles. Okay? So, and often just called opposite angles, but vertically opposite is the proper term. And you'll see in a moment we're going to be using those ideas quite a lot with opposite, adjacent, etc. Okay? So those are the first three. All right, so now let's move on. A few more pieces of terminology and some vocabulary. Generally, lines and things are named, and angles, etc., are named according to points on a line. So if we look here, we have point A and point B, and you'll notice that they have a line, and the line extends all the way through them. This is called line AB, and it's an endless straight line passing through the points A and B. Many times you'll see they have put little arrows on the end, but that's not necessary. As long as they pass through the points, then you just assume that it continues endlessly, infinitely in both directions. All right? The next thing we want to talk about, the next type of thing we want to talk about, is we want to talk about what's called a line segment. Now, a line segment is just part of a line. So if you look here, we have points A and B, and we only have the space in between. The line only goes between those 2 points. So line segment AB is the part of the straight line AB which connects A to B. Notice it doesn't continue infinitely. Okay?
First one.
So I didn't mention when I was talking about line, I forgot to mention the notation that you're going to use. Notice that this says line and then A, B in a bracket. So if it's anytime you have an infinite line in either direction, you use just a plain bracket. This is where the New Zealand system drives me crazy. Okay? But here we were talking about line segment. And notice that line segment AB has a definite stop and starting point. So if it stops, therefore it's not infinite, then you use those square brackets. So you'll see line segment and then square brackets, AB, close it with square brackets. So it has a definite hard stop at both ends. And that looks like more like a hard stop than just a plain bracket, the curvy ones, yeah? So watch your notations. Okay, so we talked about lines and line segments, but there are other types of lines and information you need to know about lines. We have what are called concurrent lines. You don't need to write this one down. It doesn't. You'll never be asked for this particular one. So I'll tell you which ones you need to make sure to know the definitions of. But concurrent lines just mean 3 or more lines that cross through the same point. These are called concurrent because they're all happening at the same time. Don't worry about that too much. And we have also what are called collinear points. Collinear means same line. So these are points that line up on the same line.
If we go with a north-south splitting there, it's a matter of just going
perpendicular lines are lines that intersect at right angles. And to make sure you know it's a right angle, we always put the little square in the corner to make sure you understand that that's a right angle. So the next one is, again, something that you're probably pretty familiar with. And these are parallel lines. And these are lines which never intersect. And you know that they're parallel not by measuring them or not by just looking in eyes, but by making sure you look for the 2 arrows. Okay, so you have the 2 arrows on each one. That's the only way, unless they tell you that they're parallel, that's the only way that you can know that they're parallel. Okay, so they have to have those arrowheads. Okay, so those are basically the past information that you need to understand. But we also need to get into what are called some geometric theorems. And these are going to be really important to you as we go. All right, so make sure, and hopefully you've seen them before. Well, if you were at UNC last year in year 8, you did.
Put the link up.
We'll look at it. And the first one we're going to look at what happens when you have angles at a point. Okay? Angles at a point, if you'll notice this,
I'll find it.
They go all the way around. So these lines, then you could have more. You could have one here and one here, one here. It doesn't matter how many there are. No matter how many there are, if they all meet at the same point, they make a full revolution. So if you added them together, they would always add up to 360 degrees. So angles at a point always add up to 360 degrees. So that's what you need to write. Angles at a point always add to 360 degrees. And you might want to do a little drawing just so that you know what that looks like. So it doesn't matter how many lines. They have 3, but you could have 27. It doesn't matter. Okay? So in other words, just think about it. This thing makes a full revolution. So it's the same idea as a revolution. The next one we need to talk about is angles on a straight line. Oops, sorry about that. And we visited this idea a little bit before. Angles on a straight line, but this time we have more than one. But if they make a straight line, you know that they're the same as a straight angle, so therefore they're always going to add to 180 degrees. So straight line always equals 180 degrees. All right, let's look at the next one. So a lot of vocabulary going on here. Remember we talked about those vertically opposite angles. Vertically opposite angles are always equal in size. So if you see this angle A and this angle B are straight across from each other, that means that those two angles will always be equal. So if I put a C and a D here, those are vertically equal as well, so C would equal D. So it doesn't matter their position, as long as they're straight across from each other, they're always going to be equal. So vertically opposite angles are always equal in size. That's critical to what we're going to be working with. You might not have seen that before. Okay. Now, the next one are called corresponding angles. Okay. So that means angles in corresponding positions will always be equal. So if you look here, you have two parallel lines, and they have to be parallel in order for this to work. And they're cut by this line, which is called a transversal. No big deal, but I just want to make sure you see it. So the bottom, you see that? This is the one on the bottom right of that set, and this one on the bottom right of that set are going to be equal. And this is why they're called corresponding angles, is because they're in the same position. Okay? And again, the lines have to be parallel in order for this to work. If they weren't parallel, then you couldn't assume that. But if they are parallel, we're going to work with a lot of those. Okay. Next one. You're so excited, I know all these definitions. Hopefully, again, all of these aren't new to you. We need to talk about what are called alternate angles. Now, alternate angles mean they're in alternate positions. So let me just show you what I mean by that. So look at A and B. A is in the bottom right of that angle, and B is in the top left of this angle, right? And if that's true, if they are indeed alternate angles, angles in alternate position are always equal. Now, this might be easier to see if you think of the opposites. For example, if you have A here, then this angle on the other side, we'll just call it C. That means A is equal to C, right? And since C and B are in corresponding positions, if I had a D here, D and B would also be opposite angles. So you can expand the ideas, and we're going to see a whole picture in a minute. I think it makes it a little easier to understand when you see the whole thing. But look at the ideas of these positions when you're thinking about, so this one's at the bottom left, this one's at the top right. That's what alternate angles mean. But I often think of it as just find that B would be in the same position. If B was in this angle, it would be right there, which means they're opposites. So they have to be the same. Perhaps that makes it a little clearer. Of course, that one would never be called B because it's in every angle has to have a different name. Okay, let's see what the next one is. Okay, co-interior. I don't even want to mess with you with this one, but you're going to see it anyway. So go ahead and get it in your notes. Co-interior angles. That means that they're the inside angles and they're both, one's up and down from the other. But if you look at these are just really angles on a line. And so they always are supplementary or add to 180. And again, I'm not terribly concerned that you can say these two angles are co-interior, but I want you to be familiar with it at least enough so that if they give you co-interior in the directions, for example, that you could then find what that means. All right? So I'm not going to ask you any questions on the assessment where it says find the if this is angle A, what's its co-interior angle? Now they might in the homework, because you're going to be able to do your homework with your notes, okay? But I would never ask that on a test. Okay, so, all right. So that should give you enough information to be able to answer these questions. But what I want to show you is, I want to show you those parallel lines with all the pieces put together. And I'm going to do it by showing you, let's see, just making a drawing of them. So I've got a line that goes here and a line that goes here. I'm going to put the little arrows on them that tell you that they're parallel, and then I'm going to cross them with a line. Now, it can go any way. It doesn't have to go that direction. They went that direction on all of theirs. Let's go this direction with ours. Doesn't make any difference. If you know the measure of one angle, then you know the measure of all of them. So, for example, let's say that this angle, it's a little over that, so let's say that it's 100 degrees. Probably isn't. It's probably a little bigger than that, but who cares? I just wanted to use easy numbers. Well, if that's 100, then I know that the angle straight across from it is also 100 degrees because they're opposites. If those two are 100, then I know that their corresponding angles are also 100. If this is a straight line and that's 100, then this one has to be its supplement, meaning that it has to be 80 degrees, which means the one straight across from it has to be 80 degrees. And since those two are the same as these, we know those are at 80 degrees as well. Now, I used really easy numbers so that I didn't have to worry about the math, but do you see the pattern? Whatever this set of angles is, it's got to be the same as this set of angles. So it's really easy to find the missing angles when there are two sets of parallel lines crossed by a transversal. Okay? All right. Hopefully that helps you see the big picture instead of all the little bits. See it in little bits and pieces like they gave it to you. So let's pop to the exercises and just find out what they do to you so that we make sure that you have enough information. Okay? State whether the angles are true or false. Okay, we did this first part of it, right? No, we didn't do any of these because we didn't have enough information. An angle measuring 88 degrees is an acute angle. Yes, because it's acute because it's less than 90. An angle measuring 92 is obtuse. Yes, because it's more than 90. The size of the angle depends on the lengths of its arms. Can everybody unmute so that you can answer questions with me now? So the size of an angle depends on the lengths of its arm. True or false?
False.
False, exactly. It has nothing to do with it at all. When a vertical line crosses a horizontal line, the formed angle is a straight angle. When a vertical line crosses a horizontal line, it makes a straight angle. Is that true or false? Think what they're saying. So we have it going across here. Okay. So is the angle formed here a straight angle? No. Yeah, because if it's crossed by that, then that means it goes all the way around. Yeah? Good deal. 2/3 of a straight angle. 2/3 of a straight angle. So you would get a straight angle. That would be true if that line hit it, right? That would be a straight angle, but not if it goes all the way through. Okay? All right. 2/3 of a straight angle is an acute angle. Well, I think we did this one, but that's okay. So if you have a straight angle, okay, And 2/3 of a straight angle would be like around there. Is this angle formed an acute angle? No way. That's bigger than 90 degrees.
Obtuse.
It's obtuse. Excellent. Okay. A right angle is neither acute nor obtuse. True or false? True. It's a special case. It's its own thing. Okay. All right. Then they're going to have you find some of these. You're going to do these by yourself, but I just want to make sure you know. So if A is 76 degrees, find B. So if that's 76, I can find B because you know that this little square means that they add together to make what?
90.
90, exactly. It's a right angle. So just take 90 minus the 76 and and that'll tell you what's left. That's the answer. So if this B is 55, you just do 90 minus 55 to find the other part. Okay? So they're going to give you some of those. If A equals B, A and B, so that means it's splitting 90 into 2 equal pieces. How could I do that? Divide by 2? Are you not brave or you just muted? If you have two, if these two are equal, that means that you're dividing this 90-degree angle in half. So divide by 2, and that'll tell you how big each one is. Then you're going to find complements, meaning they have to add up to 90 degrees. Supplements, which mean they add up to 180. Now look at this one. 180 minus what would be the supplement? Well, 180 is as much as you can get, so that would have to be 180 minus n would have to be what number? If you can't subtract anything, what does n have to be?
0.
0. There you go. Good. Okay. Then you're going to find the missing angle. And it says, give brief reasons for your answers. So in other words, you don't have to write it out so much as you should say, well, yes, you should. You should say, this is a right angle. The big angle is a right angle. So I have to subtract what I know from 90 degrees. So A equals whatever. This is a straight angle. This is a reflex, right? And if it's a reflex, the part in the middle and the part on the outside all have to add together to make what? Because you're going all the way around a circle, right?
360.
There you are, okay? And then you have some things with the parallel lines like we were working with, okay? Lots of fun stuff going on there, okay? All right, here's some unknowns. We know that one. And then we have these two that are exactly the same size, so all of them added up make 360. 360 minus the 90 I know, and then divided into 2 equal parts. And I know they're equal because they're both A, right? If it was A and B, I couldn't know that they're equal. But since they're both angle A, then I know that they have to be equal. Okay? And then they get into a little more where you're doing some math there. No big deal. Just remember that these two things have to add together to make 180. So that thing plus that thing have to equal what? So 2x minus 34 plus x plus 100 has to equal 180. So going back to your algebra skills. So they're going to make some algebraic equations for them. Just make sure you know. Now in this one, this thing and this thing, what do we know about those things? They're corresponding angles, therefore they are equal to each other. Okay? So you can make an equation and then solve it to find out what x is, and then you'd have to plug that in, substitute that x to find the angle. We might come back to that. Actually, let's come back to those. Let's not worry about those too much. So let's practice with these, because you can do some practice with these. We already did one, so here's what I want you to do before we meet again. And I know I've used up most of your time, but hopefully you can find a little time. On page 171, I want you to do 2, 3, 4, and 5. Okay? Because we already did one together. And then we'll just continue working on those next time. So if you want to go ahead and work forward, you can, but then you won't have anything new to do next time, so you don't have to. All right? but try to get at least a couple of these done. Now, even if you can't do all of them, do as many as you can. Do several of them, but don't spend hours on this. Okay?